And welcome everybody. We're back for another school year, but we're in a different location this year. We've moved from southeastern New Mexico to northwestern New Mexico. We are located now at the beautiful Kirtland Central High School. So, go Broncos! Alright, this is our first lab of the year. And in this particular lab, and I apologize already that you're not going to be able to see this very well, but if you have the lab sheet in front of you, you will be able to follow along with this, no problem. This first lab is all about 1, following instructions, and 2, can you perform the measurements and can you read the equipment that is in front of you. As you all know, we're working with the SI or metric system, which is the basis of all modern scientific measurement. There are 3 basic units. Length or linear measure is the meter. Mass or weight, and I have weight in quotes because weight is a relative or subjective term, but that base unit is the gram. Now, some textbooks will tell you it's the kilogram, but we're going to use the base unit. Volume, or the space contained within something, is liters. But also, if you said cubic volume, we would go with that. Remember, in the metric system, we have 2 forms of measuring temperature. We have the one that we're going to use, which is Celsius, and there's also the Kelvin scale. Remember Dr. Celsius? He wanted his scale to have water freeze at 0 degrees Celsius. Dr. Kelvin, he thought, you know what, 0 really needs to be absolute 0 when all matter stops. But anyway, Dr. Celsius also wanted water to boil at 100 degrees C. Time is measured using the base unit of seconds. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, and 365 days in a year, or 52 weeks in a year. So there you go. That's the first part of that. And we go through all of this. I went through this now with 6 classes. So there you go, or 7 classes, I think it is. 2 in the morning and 4 in the afternoon. That's 6. All right, now we're going to get down into this chart. And I want to thank the teacher at Dove Creek High School in Colorado. I got to his website and I saw this chart, and I kind of borrowed his chart, so I want to just give credit where credit is due. But anyway, on this chart, everything we need to know about the metric system for use in the science lab. The basic unit of length, again, is the meter. If you're doing this at home, you can follow along. The basic unit is a gram for measure or mass. And then the basic unit for volume is the liter. Now, as we go across, the symbol for meter is an M, symbol for gram is a G, and the symbol for liter is a capital L. It's a capital L, so we do not confuse the small l with a 1 or an I, so it's a capital L. The value name, well, all of these are worth 1. They are the base unit for each one of these. The value number, well, of course, that's a 1. And in scientific notation, 1 is 10 to the 0. Going up, as we go up above our basic unit, these are called super units. We have deca, D-E-C-A. Its symbol is D-A. Its value is 10. Its number is 10. That makes it 10 to the first. Then we have hecto. Hecto is a small h. He is worth 100. His value is 100. And in scientific notation, that is 10 to the 2. 2 meaning 2 zeros after the number, or 2 places after the significant primary number. Then we have kilo. Now, I've seen the symbol for kilo either be a capital K or a small k. I think nowadays we're trending toward the small k. It is 1,000. The value, therefore, is 1,000. And in scientific notation, that is 10 to the 3. The one above that is mega. Its symbol is a capital M, and keep track of the M's. We've got an M here, an M here. We're going to have another one in a moment. It's worth 1,000,000, which makes that 1 with 6 zeros. And in scientific notation, that is 10 to the 6. Now we do the subunits, so underneath it's deci. Deci's symbol is a little d. Its value now is a tenth. As I was telling my students today, if you said 1/10, technically you're correct. However, that's a fraction, and in Science Lab we do not deal in fractions. Therefore, let's keep it real and call it a tenth. Its value is 0.1. Now, for significant figure fans, we'll want that 0 there to hold that place. I've told my students if you turn it in as 0.1, I will accept it. And again, different teachers teach it different ways. I'm making sure that they know both. 10 to the minus 1 is the scientific notation. Centi is the next subunit. It is a C. It is a hundredth. It is 0.01 or 10 to the minus 2. Then our favorite milli, everybody knows milli. She is the little m. Now again, we have 3 m's. We have a capital M, we have an M for meter. Capital M is for mega, M for meter, and we have an M for milli. So make sure you can keep track of your M's in the metric system. Milli is 1,000th, which is 0.001 or 10 to the minus 3. Then we have micro. Now micro uses a symbol that I call a backwards Y, but it's the micro symbol. In Greek, micro meant very small and macro meant very large. Micro is millionth. That's 0.0000001 or 10 to the minus 6. In this case, the minus 6, we're going to go 6 places to the right of the decimal. 1, 2, 3, 4, 5, 6. And there is our 1. And then finally, we're going to have nano. Nano is a little n. Do not confuse nano with nana. Okay, nana is a whole nother thing. Nano is 1/100000th. And nano is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 to the minus 9th. So here you have it. This is our major chart with all of our major values in the metric system that we will be using in class. At the bottom, which you probably can't see very well on the camera, this is just telling the students that we're going into the lab area, that if we're performing mathematical calculations, I will give them the formula. If you need to round, I ask them to round 2 places past the decimal, but for density and area calculations, I would like them to round up to the next whole number. And under no circumstances will fractions be allowed, because this is science and we use decimals. I also tell them that in my laboratory, I may, notice the word may, ask them 1 time to stop if there's any kind of fooling around going on. But obvious pushing, shoving, or deliberately interfering with somebody's ability to participate, and we go straight to the referral status. And this is the first of the 4 pages of our science lab. And in just a moment, we'll go to part 2, and we'll start running through the stations. Once again, It's great to be in Kirtland, and it's great that you're watching us this year.